Hi everyone, my name is Louisa, and today I'm going to be talking a little bit more about Ohm's Law and when we can and can't apply the equation voltage equals current times resistance. So the first thing I want to mention is that not all materials hold true for Ohm's Law. So essentially there are materials called ohmic materials where the equation voltage equals current times resistance is true. These are typically metals, and for the purposes of an introductory or early physics class, you can assume that any metal or conductor that you're given is ohmic. But it's good to know regardless that Ohm's law isn't true 100% of the time in the real world. The trickier concept is knowing when you are or aren't using the same scale for voltage, current, and resistance, because Ohm's law is only true when voltage, current, and resistance are from the same scale. I'm going to explain what that means in a lot more detail. What I have here is a very simple circuit with one resistor. So this is actually an example of when you don't need to worry that much about scale. And I'm going to show you this one and then compare it with a more complicated example. So the voltage here is VB, voltage of the battery. I just needed that. And the resistance of this resistor is R1. So what I'm going to be doing is writing down the voltage, current, and resistance of the entire circuit on the left side, and writing down the voltage, current, and resistance of just over the resistor on the right. So let's start with the voltage. We know that the voltage for the entire circuit is voltage of the battery. Now, for over the resistor, we can see that since there's only one resistor, it's the only thing that's going to provide a voltage drop. And since the voltage needs to be VB for the entire circuit, we can determine that the voltage drop across R1 is also VB. Since there's only one path for current to flow, we can also tell that the current is going to be the same for the entire circuit. So there's no other alternative path for current flow. So the current for the circuit is going to be just I, and then the current across R1 is also going to be I. There's no other way for current to flow in this case. And the last thing we need to take a look at is resistance. There's only one resistor, so there's no need to worry about it being in series or parallel. There's just one. So the resistance of the circuit is R1, and the resistance of the resistor is also R1. So you can see in this case it looks like you don't need to worry about scale because the voltage, the current, and the resistance are the same for the individual resistor and for the entire circuit. This gets a lot more complicated when you add more than one resistor into the circuit. I'll be explaining that case in part 2 of this video.